This video is on balancing redox reactions. By the end of this video, you should be able to balance simple redox reaction using either ion-electron method or oxidation number method. I might ask you some questions. Which means of transportation do you use to get to school? Some of us go biking, while others go walking. Others even use commercial transport means. But our goal is to all reach to the same destination, that is the school. That is why two methods are used in balancing redox reaction. And all is to get a balanced reaction. It might be easy using ion-electron method or the oxidation number method. Now let's take them one by one. Now to ion-electron method, which involves charged particles. In balancing redox reaction using the ion-electron method, it involves splitting the redox reaction into oxidation and reduction halves, if you could remember our first video. And this involves 6 simple steps. One is assign oxidation number to each atom of the element that has changed in the equation. Throughout, consider the equation below between iron 2 plus and chlorine molecule to give iron 3 plus and chloride ion. Assigning the oxidation number, we have 2 plus. If we could remember the rules in oxidation number for iron, that for every charged particle, the oxidation number equals to the charge of the ion. So same for iron 3 plus and chloride ion. And for chlorine molecule, it follows rule 1 that element in the free or uncombined state, it bears the oxidation number of 0. Then to step 2, we separate the reaction into oxidation half and reduction half. We do so for half equation. Each reactant on product side bears its like term. For the oxidation half, we have iron 2 plus to give iron 3 plus, and for the reduction half, chlorine 2 to give chlorine minus. Now to step number 3. Balance each half of the reaction as follows. 1. We are to balance the number of atoms on both sides so as to confirm the law of conservation of mass. Then 1, if it is 1, it should be 1 at the reactant side. If it is 2 at the reactant side, it should be 2 at the product side. For the oxidation half, the atoms here are balanced. For the reduction half, however, atoms are not balanced. A molecule of chlorine produces 2 chlorine ions. So we should balance it. So chlorine 2 will give 2 chlorine ions. Now the atoms are being balanced. Now, in this aspect, the charges has to be balanced too. So we add appropriate number of electrons to account for the number of electron lost or electrons gained. That is, we have to balance charges. For the oxidation half, iron 2 plus gives iron 3 plus. There is loss of electron in this aspect. So iron 2 plus to give iron 3 plus, we need to add additional electron to balance the charges. In this aspect, charges are balanced. Plus 2 at the reactant side to give plus 3 minus 1, meaning plus 2 at the product side too. And for the reduction halves, chlorine in its uncombined state is 0 charged. However, it gives minus 2 chloride ions. So we have to balance charges. So we add additional 2 electrons to the more positive side, that is to the reactant side. 0 plus minus 2 is equal to minus 2 at the reactant side and minus 2 at the product side. So here the charges are all balanced at the oxidation half and the reduction half. Now to step number 4. Multiply each half reaction by the appropriate coefficients to balance electron loss and electron gained. For the oxidation half and for the reduction half, as we have done in 3b, there is a loss of electron in the oxidation half and a gain of 2 electrons in the reduction half. So we have to balance the electrons. So we multiply oxidation half by 2. If we multiply by 2, Then we add the two-half reaction, cancelling the common terms, that is 2 electrons. This is our step 5. So we get a net reaction. We add up both the oxidation and reduction halves together, bearing the reactant side and the product side. So we check on the charges. Are the charges now balanced? This is our step number 6. We have to note that both the number of electrons and charges at the reactant side are same as that of the product. Now to oxidation number method. Oxidation number method follows 3 basic ways. And this simple method is used without splitting the redox reaction. This method could sometimes be tricky. Now to step 1. We assign oxidation number to each atom of element that has changed in the equation. Magnesium with 0, iron plus, silver plus with +1, magnesium 2 plus with 2 plus, and silver with 0 oxidation number. Then change in oxidation number of magnesium in the reactant and product side is +2 minus 0 equals to +2. There is loss of 2 electrons, and for the silver there is gain of a single electron. So the charges here are not balanced. Then we get to step 2. To step 2, in this aspect, we should equalize changes in oxidation numbers. For each atom of magnesium oxidized, 2 atoms of silver ion must be reduced. So we multiply silver atoms by 2. And then to the final step, we check on the charges, both at the reactant side and product side. Now let's have an exercise. Apply the steps and balance the redox reaction below using either ion electron method or oxidation number method. You should use your time. And feel free to go back to the video if you are confused.